Okay, so now what we're going to be talking about is implicit differentiation, and this is just another way to differentiate, obviously implicitly. So let's see, implicit differentiation. Okay, differentiation. Okay, yeah. This is, like I said, it's another method to find the derivative of a function. But first you need to know what is implicit form. So this, obviously, hence the name, you can only use it when a function is in implicit form. An example of functions that are in implicit form are xy equals 1 or x squared minus 2y to the fourth plus 3y equals 4. Basically, both variables are on one side of the equation. It's not something that's explicit. So an example of an explicit is kind of more of the common functions that you've seen recently, kind of like y equals 3x plus 5. These kind of functions you cannot use with implicit differentiation. Now, given an implicit formed equation, there are steps that you want to take. The first step is to differentiate both sides with respect to x. So first I'm just going to kind of tell you this, and then I will show you how to do this within an example. The first step is just to differentiate both sides with respect to x. Then you would like to collect all terms that involve dy over dx on the left side and all other terms to the right side. Then your third step is to factor dy dx out of the left side of the equation. And then you finally would like to solve for dy dx, and you will get your derivative. Okay, so now that I've kind of gone through the steps on how you implicitly differentiate, I'm going to show you now with an example. So, okay, so let's say the example is to find dy dx by implicit differentiation, and let's say you're given the formula, the function x to the 1/2 plus y to the 1/2 equals 16. Okay, so what you're going to do first is we are going to differentiate both sides with respect to x. So you're going to have dy dx times x to the 1/2 plus dy dx times y to the 1/2 equals dy dx times 16. So all we did here was the first step, which was to differentiate both sides with respect to x. Now, what we're going to do, if you look at this, since these variables agree, you can use the simple power rule to simplify this. So what you're going to get here is simply 1/2 x to the negative 1/2. So we just brought the 1/2 in front and subtracted 1. Simple. Now here, on the other hand, the variables do not agree. So when the variables don't agree, so this is an x and this is a y, you're going to have to use the chain rule. So what you're going to get here is 1/2 y to the negative 1/2 times dy dx. And using the constant rule, the derivative of any constant is 0, so this equals 0. And so in this step, I use the power, chain, and constant rules to come up with this line. Now, to make things simpler, I will multiply both sides by 2. So I'm going to multiply this whole thing by 2 and multiply this whole thing by 2, so I don't have to deal with these 1/2s. It'll just cancel things out, make it a little more simpler, a little bit more convenient. So I'll have x to the negative 1/2 plus, 1/2 plus y to the negative 1/2 dy dx, you cannot forget this because you had to use the chain rule here, equals 0 because 2 times 0 is 0. Then your next step is going to be to isolate dy dx. So when you isolate dy dx, so you're going to subtract x to the negative 1/2 and divide it by y to the negative 1/2 to isolate. Simple algebra that we've learned before. It's just like isolating a variable. So when you isolate dy dx, you're going to get dy dx equals negative x to the negative 1/2 over y to the negative 1/2, which when simplified equals negative square root of y over x. So your derivative, dy over dx, is then just negative square root of y over x. And that is how you implicitly differentiate.